So good afternoon, everybody. My name is Prudence, and I'll be your host today. I would like to welcome you all to the fourth talk in our series on African geology and soils. As always, a hearty welcome to our primary audience, the students at the Tshwane University of Technology and Tobile. Today's topic will be on the story of the Savanna Vegetation with a focus on the Kruger National Park, and it will be presented by Dr. Coetsee. Dr. Coetsee is an ecologist with a decade of experience at South African national parks in the Kruger National Park. Before that, she taught at the Nelson Mandela University and continues to collaborate with them. Dr. Coetsee's work revolves around plants and animals in nature. She studies how plants defend themselves and how animals use them. She's also looking into how animals like elephants affect plant life. Besides that, she's interested in fire and plants interaction and how this has implications for climate change solutions. So please give a warm welcome to Dr. Coetsee, and you can share your screen.
Okay, so welcome everyone. I'm going to start with my presentation. I am going to give this lecture, and I hope at the end of it you are going to understand a little bit better how vegetation interacts with soils and climate. And as you heard from Prudence's introduction, I'm really much more vegetation ecologist. So although I'm going to talk about geology and soil, I'm not that knowledgeable, and I understand geology and soil as how it relates to vegetation. So, and then I also have this focus on Savannah, because I am based in Savannah. I do most of my work in Savannah, and I understand Savannah's the best. And there's different, what is called bottom-up and top-down drivers that's important for how savannas are shaped. Bottom-up drivers are those things that's inherent to the system that you can't really change. So that includes soils and climate. Where top-down drivers of vegetation in savanna includes disturbances. And if I show you this next slide, you can guess which disturbances are important for savannas. We can see fire here in the picture. And then also, if you hear anything about Kruger, you usually hear about animals. So animals is the other disturbance that's pretty important for savannas. And I'm just going to look at these two bottom-up drivers, climate and soils. And if we start with climate, we know that South Africa doesn't have the same amount of rain everywhere. And the reason is quite simple. If you look at this next map, we've got these two ocean currents. The one comes from the South Pole, and it doesn't carry much, because it's such a cold wind, if you can call it that, it doesn't carry much water vapor. So when it reaches the Cape, you usually have most of the moisture that is carried on that in that current deposited on the Cape, and then as it moves past the West Coast, there's not much water vapor to actually create rain over that West Coast. Where the current that comes down from Mozambique, that's a warm current. It carries a lot of water vapor, and you get a lot of rain on that coast. So if we look at the map, we can kind of see that reflected in the rainfall map for the country. So you have this very dry western part of the country, and with typically receiving its rain in the winter months, and then on the eastern side of the country, summer rain and much more rain. Then if we look at soils, plants obviously grow in soil, so soils is very important for vegetation. What is soil and how is it formed? So soil is just that thin layer of material that covers the Earth's surface, everything that is not actual rock. and it's made up out of mineral particles. So the minerals come from the weathering of rock that is already present in the soil. And then there are things that actually is added to soil over time, like organic material, air, water, and organisms. And you can see in this picture, soil usually have these different horizons. So the better developed your soil, the clearer you can see these different horizons. Okay, so how is soil formed? So the most important thing is soil is formed from the weathering of rock, and you get different kinds of rocks, igneous, sedimentary, and metamorphic. And for the purposes of our story, we're going to talk a little bit about igneous and sedimentary rocks. But soil might form from the weathering of these rocks, or soil might come from somewhere else. So you might have sand blowing in, or you might have a river depositing some alluvial material, making up soil. Okay, so if we just quickly look at types of rock, igneous rock is a rock that's formed from magma, and you get different kinds. You get rock that's formed when magma cools in the surface of the earth. It usually cools quite slowly. It's called intrusive then because it doesn't come out of the surface of the earth. And an example that you might all have heard of is granite. So granite forms deep in the crust of the earth. It cools slowly. It has quite a rough texture, where basalt is a different kind of igneous rock that is often formed. It's spewed out of the surface of the earth. It cools quite quickly, and it's very it forms this very fine textured rock. And then another rock that's very important in South Africa called shale is a sedimentary rock, and it's formed from mud. And shale is important for us. It's not only quite a nutrient-rich, or forms nutrient-rich soils, but it's also where most of our coldest deposits are. So part of the reason that we have load shedding is that we can't get the coal out of that shale deposits quickly enough, and then we burn it in and make electricity. Okay, so if we look at this map of South Africa, those granite rocks are these pinkish colored ones right at the bottom. If you look at this long time series, the rocks at the bottom are the oldest rocks. So they were formed first, and then as you go up, these ones at the top are the younger rocks. And these granite rocks were actually formed way before Gondwana even broke up. They were formed as the earth was formed. And some of the other rocks that are important for us are basalt, that we're going to later also look at in Kruger. Actually, maybe I should just mention that before Gondwana land broke up, you had like wet periods where these huge inland lakes formed, and the mud that later formed the shale will lay down then. And then later on, when Gondwana land broke up, and when these crusts were pulled apart, the basalt actually were pushed out through the cracks that formed when Gondwana land split up. And that is quite important for us because the older our rocks, the longer time they've had to weather and for the nutrients to be leached out. And the younger the soils are, the younger the rocks are, the more nutrient rich they are. And we'll come back to that in a little bit. Okay, then the second thing that's quite important for soils is organisms. You have all kinds of organisms that move through the soil. They create some little channels in the soil. They move the soil, they mix up the soil. And these aren't only animals, but also plants. So you have plant roots that penetrate the soil. These plant roots might die over time and add more organic matter to the soils. You have some litter from above ground. When plants die, the litter falls onto the surface of the soil, and these animals like earthworms will take that litter and incorporate it into soil. So those different organisms are quite important for forming soil. And this is kind of a classic example of succession. So you see a volcano here. It's you have an eruption of magma. Over time, that will form rock. And at first, there's nothing that grows on the rock. And then after some time, you might get something like lichen. I don't know if you guys remember that lichen is a symbiotic relationship between fungi and something that can actually make food like cyanobacteria or algae. So the reason why lichens can grow really well on this rock is they don't have roots. So they just come, grow on top of the rock. Over time, they release acids that start breaking up the rock. They might die and decay, and that material is added to rock. They also, because they have these rough surfaces, they catch maybe sand that's blown over the rock. So over time, they actually help to build soil. And then something that's very important for us in Kruger, there's a little picture here at the bottom. Those red little round spots are termite mounds. This is southern Kruger, and you can see that about a fifth of the area there is somehow under the influence of termite mounds. The termite hajj has a huge effect also on soils. They make these very deep tunnels. They move nutrients around. Animals can use their tunnels to access the soil. They're usually in the mounds. They bring clay up. They bring nutrients up. They take a lot of the above ground vegetable matter back into the soil. So they are very important in forming soils. Okay, and then the third thing that's important for soils is climate. Rainfall and temperature is the most important. And I think in South Africa, it's always warm enough to have, or most places, to have soil form over time. So if you have very cold conditions, we'll look at some soil, different types of soil just in the next slide. But if you have very, very cold conditions, then you can't really have soil developing over time, because you need these chemical reactions to happen. You need vegetation to grow on the soil to actually help form the soil and weather the soil. So you need moisture and warmth for soils to form. In South Africa, where it's warm almost everywhere, rainfall becomes very important. And then if we look at this, so this is just kind of a diagram. On the left, you have soils that's not that well developed. And the reasons might be that it's very dry, so you don't have the water there to actually help on these processes of soil weathering. And it might also be that it's very, very wet. So when it's wet all the time and you have anaerobic conditions, then you also can't really get a breakdown of soil. But now savannas, we're mostly on this right side of the diagram. And the molly soils there, the dark soils and the verti soils, those are the soils that is formed from basalt. And then this oxy soil kind of on the right here is some of the soils that we find on granite. Okay, then the fourth important factor for soil formation is topography. So you can see this photo shows quite nicely on these very steep slopes, you don't really have soil. There's no way for the soil to actually hang on to. It will just be eroded away. And topography is also important for some slopes are always warmer than others, depending where you are. So in the southern hemisphere, our southern slopes are usually cooler and wetter. They usually have more vegetation, and they might also have more soil on them. And I thought I'll just show you this picture that I took when I was visiting Madagascar. So you can see here, people are doing agriculture on these low-lying plains. And then they also try and go up the slopes. But it's actually quite hard to work the land there. And it's also quite bad because the soil just is washed away and it's just leached on those steepest slopes. So you typically don't have very deep soils on slopes. And if you fly away from Madagascar, you see the rivers actually, because people do agriculture a lot on the slopes, there's a lot of erosion. And you can see the soil just washing out into the ocean with all the mud and soil that's in the rivers. Okay, and then the last factor that's important for soil formation is time. So if you think back to that little slide that I showed you about the succession after the volcanic eruption. So there in the beginning you had not much soil. And then over time, soil was formed. So, and this might take thousands of years before you have nice deep soils. And you have all those microorganisms that help to form soil. And a well-developed soil is one where you can see quite clearly these different horizons. The A horizon is usually that dark horizon that is very much an effect of the vegetation growing and all that litter and roots being added to the soil. Okay, so we have now talked about climate and soil. We're going to look a little bit at how these interact at different scales to give rise to certain vegetation. I'm going to start a little bit broadly at the biome scale. So I'm sure, as I haven't actually even asked, but I assume these are nature conservation students. I'm pretty sure you've looked at biomes, and I quite like the second definition on the slide, which I've taken from the big vegetation of South Africa book that Messina and Rutherford did. So they say a biome is viewed as a simplified unit of similar vegetation structure exposed to similar microclimatic patterns, often linked to characteristic levels of disturbance such as grazing and fire. So we've kind of talked about all of those things. So I'd kind of bring those bottom up and top down drivers together. And we have these different biomes in South Africa, but I'm talking about today is specifically Savannah. And then there's also grassland, and I think it's sometimes a little bit confusing because you can also find grassland or quite open systems in Savannah. But if we look at this map, the orange is your typical savannas where you have some, I would say the conventional distribution. Now it might look a little bit different because we've had a lot of trees coming into grassland and a lot of alien trees. But the orange is your distribution of savanna. And in savannas, you usually have a mixture of trees and grass. So savannas can be quite open. They can look like grasslands, but there's still a few trees. And then they can be almost like covered woodland where you have a canopy that almost meet and starts to look like forest. But as long as you have grass in that system, that's still viewed as a savanna. And if we just look at this Whittaker graph, if you combine precipitation here, rainfall on the left, and one thing to notice, this is actually centimeters. So this 100 centimeters, 1,000 millimeters. So that is just about the most rain that we will get in South Africa. And then temperature. You can see there with the red woodland, shrubland, and the kind of khaki color, the tropical season of forest and savanna. So that is the kind of envelope where we will find savanna. So you get different kinds of savannas. People talk about nutrient poor and nutrient rich savannas. It's also called sweet veld and sour veld. And I thought the migration in Serengeti just illustrates quite nicely how important it is in terms of these different types of savannas. So what we find in the Serengeti is animals actually prefer the nutrient-rich savanna. So they are in the south when there's the southern savannas in the Serengeti is nutrient-rich savannas. They have soils that is quite recent, that's from volcanic origin, and they concentrate on those plains. They eat the very palatable grasses. But then at one stage, as the dry season arrives, they finish the food, they finish all the good food, and they have to move. So they move up to the northwest, and those grasslands are actually on granite, and they're not that nutrient rich, but which is maybe a good thing because animals will only move to them when they have to. And because they're not so nutrient rich, they still have quite a bit of grass. And then eventually when animals finish that, they will move all the way up into northern Serengeti. And then when the rains return, they actually move back to the south. And we will talk a little bit about these nutrient-rich, nutrient-poor savannas also in Kruger. But all in all, it gives rise to a very productive system. If they only had nutrient-rich savannas, they'll probably run out of food because there'll be animals everywhere in the Serengeti. And if they only had nutrient-poor savannas, then we probably wouldn't have such high numbers of animals because the system wouldn't have been that productive. Okay, but the Kruger National Park is this great example because we have these two types of savannas next to each other. And I'm just going to show you a map. So this map on the right shows us the geology. So you can see that gray color is the basalt and the orangey color is the granite. And the basalt is these younger soils, finer texture, they're quite clayey, they retain a lot of nutrients, where the granite is like a very rough textured, very sandy soils that weathers from the granite. Doesn't hold well onto water, doesn't hold onto nutrients. It's quite nutrient poor. And then there's a bit of the yellow in the middle, some of it is shale. And then we also have a rainfall gradient. So southern Kruger is quite a little bit wetter than, and then the rainfall decreases as you move northwards. And the kind of most important soil types is basalt and granite. And there's also rhyolite and gabbro. And they're interesting types of geologies because gabbro is chemically very similar to basalt, but it's formed like granite. It's also formed within the crust of the earth. And then rhyolite, which forms the Lubumba Mountains on the eastern side of Kruger, is chemically the same as granite, but formed like basalt. And then something that maybe just to remember is that granite and rhyolite is rich in silica and mica. So those are things that's very glass-like. So if you think of glass, it doesn't really remind you of nutrients. Okay, and you can't think that much can stick onto glass. Where the chemicals that you find in the other rocks in the basalt and the gabbro. There's a lot of, it weathers to clay, and has a lot of minerals in those rocks, like magnesium, calcium. Okay, so if we look at the broadleaf savanna, as I said, it weathers from granite. It's a very kind of gritty, sandy soil, especially in high rainfall areas. All the good minerals, and there's not so many to start with, is leached out. And so there's very low nutrient availability. And people also talk about broadleaf savannas, and they talk about these sandy savannas. And you can see a nice example here of, you know, immediately on a granite or a sandy savanna, because the road has got that kind of sandy color. And I've just given you an example of a soil pit. If you look at it more closely, you can see that kind of gritty, rough texture. Okay, grass grows tall. We classically have thatch grasses on the granites. They're not good for animals to eat. They have a lot of very fibrous material. They don't have a lot of nutrients in them, not a lot of protein. So you usually find less animals there, and low diversity. On the fine leaf savannas, on the other hand, the ones that you find on the basalts, you've got a very fine soil. This soil, you can see in this picture here, the soil's kind of, they swell up and then they shrink back again when they dry out. And that creates these cracks in the clay soil. But because they have such fine texture, they actually manage to hang on to nutrients. And that means that the plants that grow on them is more nutrient rich, and they're also quite productive because they have a lot of nutrients. Things can grow very fast, especially if there's enough rain. And you usually find a lot more animals on them, and a high diversity of animals. And you can see here how dark that soil is. So when you add water to those dark soils, they're going to turn into clay. It's places where you really struggle to drive your car when it's wet. Okay, and then almost following this geology map, if you can call that, is also a vegetation map. And this is just the landscapes of Kruger. That was this work was done by a man called Gartenbach, and he's went and looked at soils and then measured the vegetation that grows on the soils, and he came up with these landscape types. And I'm only looking at a few. So there's Euphorbia bushwillow mountain bushveld on the rhyolite. So that is on these rhyolites that they don't weather very fast. They actually they're some of the highest places in the park, called the Lebombo Mountains. And if you then come off the bombos onto these plains, the basalt plains, you get knobthorn, which is one of your thorn trees, and marullas. And then if you move to the middle, there's some shale there, and there's again a very specific vegetation type that associates with shale. And then when you go all the way west, you find some low-veld sour bushveld. So remember I said that nutrient poor savanna is also called sour. It's called sour because the grasses aren't very palatable. So you find these broadleaf woody species in the sour veld. And this is just an old Kruger used to have this map called ecozones, and someone actually put together the soils and the veg, and then also with what animals you can expect to see. And the map showed you then like each ecozone and what you could expect if a tourist comes to Kruger, they drive in that area, you know, what the veg would look like and what kind of animals which they mostly encounter. But then, just to make it a little bit more complicated on the granite soils, because the soils are so roughly textured, when you have rain falling on the soil, it's easy for particles to move through the soil, because remember I said that those particles are a bit glass-like. They don't actually hang on to things. So the finer, if there's any finer material in the soils, they will be washed down the slope. So over time, then you end up with all the finer clay washing out to the bottom of the slope, and all the coarser sandy soils remaining at the top of the slope. And somewhere here in the middle, where you have the coarser soils meeting the finer clay soils, because the clays don't absorb water as easily as the sandy soils, you have, especially if it's wet, you have some moisture coming out. We call that a seep line. And we've had a very good season of rain in Kruger. So even now that we're in the dry season, you still find water running out of these seep lines. And so on the granites, I said earlier that they are called broadleaf savannas, but because of the Katina, you will still find more thorny trees on the bottom slope on these clay soils closer to the river, and then broadleaf plants on the top of the crest, on the top of the hill. And then there's very specific vegetation on the seep line that actually likes these wet conditions. There's some hydrophilic, like water-loving grasses that grow there, and there's something called silver cluster leaf that especially like growing on the seeps. And they actually need, for their seeds to germinate, they need long periods of being very wet. So I think this is probably going to be a season. We've now had months of water on the seeps. We're probably going to have pretty good germination of the cluster leaf, the silver cluster leaves. And we can just go back. So here, closer to it kind of flattens out at the bottom of the slope. You also have these places called sodic sites. And sodic sites have these duplex soils where they have kind of coarse textured horizons that's quite sandy. And then under that, they have quite fine clay soils. And the clay soils have a lot of salt in them. And the salt makes that they don't stick well together. So they actually, there's something called deflocculation. Okay, so the sodium because there's a lot of sodium, the sodium particles almost push each other away. Where if you had soils with a lot of calcium, for instance, then that those particles pulls together. So on the sodic sites, that's places where animals really like to go there. But if you have a lot of trampling, or even if you have a road, you usually end up getting erosion, because that coarser soils that protects the biohorizon then gets taken away. And then those soils erode very easily. And then if we just look at smaller scales in our savannas, there's still soils being very important here. So this is just a picture of a termite mound, and you can see how that on that termite mound, it almost looks like someone's cut the lawn there, or the lawnmower. But that's animals, because the termites bring nutrients and clay onto the mound. It's very fertile there on the mound, and those grasses are very nice to eat. They're very palatable. So you have animals congregating there onto the termite mound. And it's the same with, for instance, pans in the landscape or wallows. You also have a lot of nutrients washing into these pans. Sometimes there's a lot of salt there, so animals like to come there, and they keep the grass short. So these are the smaller scale hotspots, if I can call it that, nutrient hotspots in the landscape. Okay, so those are our bottom-up drivers, and I'm just quickly going to talk about top-down drivers. And Herbivory is the first one. here on the left, it's actually a root. This is a massive, so the above ground parts were quite small because the herbivores and fires were coming and always disturbing the above ground parts, but the below ground part, the root, became very large because this tree was just trying to put a lot of resources into the below ground parts where it's safe from these disturbances. And then we have some exclosures in Kruger, and they show quite nice the effects of herbivory. So if you look at number A here, this is a LiDAR picture. So the pinker stuff is woody vegetation, and the greener stuff is where you have less woody vegetation. So you can see here in picture A and picture B, it definitely is much pinker inside, so there's much more woody vegetation. Outside, you have quite large herbivore effects. And both of these are actually, the top one is on basalt. And there's a lot of animals at that site, so you can see that quite nicely. Picture D here on the bottom, that's actually on granite, and if you look at the inside and the outside, it's very similar. So there wasn't that much of a difference because there's not a lot of animals that like to be there, so they don't have such huge effects on the vegetation. And then number C is also on the granite, but it's very close to rivers. You have more animals there. Sorry, and you can also see inside is much more woody, many more trees than outside. So herbivores have a huge effect on the landscape. This is that top exclosure over time. I'll just show you a little time series quickly. So the fence was put up, I think, in the 70s. And then over time, you can see that just from the vegetation behind the fence is protected. Okay, and then you can see over time it just gets thicker and thicker in that vegetation. And there's a massive difference between vegetation inside the exclosure that's protected from animals and outside the exclosure. And at one stage, if you didn't know, you would get to this side and you'd think, oh, maybe it's just too wet for trees to grow. But actually, it's just this interaction between that wet clay soils and the herbivores make it quite hard. Then for vegetation, when they're protected, trees can still grow. But outside, there are just too many stresses for them. And then the other very important process in Savannah is fire. Especially on the basalt, you have where you don't have many animals, you have these very high biomass, high fuel loads. And there are huge areas of the park that burn, and they burn at different frequencies. So the red areas on this map is areas that burn almost every year. The red pinks is every second year. And then some places in the park almost never burn, so you can go for more than 20 years without fire. But fire is a very important process. It rejuvenates the grass layer. It keeps the savanna open. We don't want to lose our grasses. There are many animals that actually prefer eating grass. And so it keeps the woody layer down. And you might have heard of a process called bush encroachment that's quite prevalent in savannas now. So trees just grow very well at high CO2. And what we see in the savannas of Kruger is that we get more and more shrubs and bush coming in. And in areas that used to be quite open, where you had nice grassland, they are now completely covered with bush. So we're also trying to use fire to try and curb the bush encroachment. Okay, so just to kind of pull all these things together, we talked about climate and soils, our bottom-up drivers, and then our two top-down drivers, animals and fire. And when you think of the vegetation that you see, you kind of have to put all of these things together. Because if you look at only one, you might just think, we have a lot of rain, so this is going to be a very productive system. But actually, your soils might be quite poor, or there might be other reasons why that affects the savanna. Yeah, and then just lastly, before I stop, I just wanted to again say how important it is. We are in this age where a lot of people are anti-fire and they're trying to suppress fire. But it's so important for open systems like savannas and grassland to keep them in that state. And if we try and keep fire out of them, they are going to become something completely different and not function as they should. Okay, and that is my talk. I think I try to time it so that we can still have questions.
Yes. Thank you, Dr. Colley, for your very informative and insightful talk. I know you're very passionate about making science relevant for all. And if you must know, I'm not a conservation student and I learned a great deal from hearing you speak. So thank you. I would like to officially open the Q&A. If anybody has a question, please use the reaction tools to lift up your hand. If you have a question, you can put it in the chat and I'll read it out loud. Thank you. Oh, Sial, you can take your question.
Hi, Colley. First of all, thank you so much for that talk. Yeah, as Prudence said, really, really informative and super interesting. I know you sort of alluded to it pretty much throughout the whole talk, but with regards to sort of climate change and changing weather patterns and rainfall, what kind of effects would that have on the savanna biome or all biomes?
It's quite a hard question to answer. So in the first place, I think we are seeing climate change playing out in the way that the bush layer is becoming really thick, and that's completely. I think it's been shown that is CO2 driven because trees just grow really fast when they have a lot of CO2, and there's not really an advantage for grasses. They've been designed to function at low CO2, so they're not necessarily growing better under high CO2. I think that is one thing that changes the whole system completely. Like all those animals that you have that prefer open system, they now have to deal with something where, cheetahs, they like to hunt in the open, but now all of a sudden they have this very, very thick bush. So I think that's one big factor. And then the other thing is also we see in Kruger this interaction between fire and elephants in leading to mortality of large trees. So we have this interaction between elephants and trees. So the moment elephants damage the tall trees, then you then get fire. Fire tends to have a much bigger effect on the trees and end up killing trees. And I think that fire, the whole fire regime is also affected by climate change. And I think in certain places in savannas, that is also going to play a role in changing the vegetation. So fire is a good thing, but I just think, if rain starts to decrease or increase, it's a little bit for our savannas. I don't know what it is like in Kenya, but for our savannas, we're supposed to get the same rain, but it will be distributed differently. So we might get these more intense events and get our rain in shorter events. So I guess it'll only be time will tell what the effects will be, for fire and for trees.
Yeah, exactly. Thank you very much.
Thank you, Colley. We have a question in the chat from Babalo. He says, good afternoon. Thank you for a very informative talk. Just out of curiosity, which examples of grass species would you find in a sodic site, and do they change with time?
So you find very specific grasses on the sodic sites. They are usually what we call stoloniferous grasses, and those are grasses that I think the best example would be lawn grasses. So because animals really like to be on the sodic sites, they're always there, they're always grazing. The grasses that grow there is adapted to actually grow like lawn grasses. You know, they won't grow up, they kind of just creep along on the ground. So Cynodon is one example. And there's other, or these lawn grasses that grow on the sodic sites. I hope that answers his questions. Thanks for your question.
I have a question. I just want to know what was there a specific incident that sparked your interest in the vegetation dynamics as an ecologist, or was it just, yeah, I want to know what got you to doing what you're doing.
I think that I came even as a child to the Kruger National Park. My parents brought me here during holidays, and so I knew what an ecologist was.
Yeah.
And from the time that I was in primary school, I said that I want to be an ecologist and I want to work in the Kruger National Park because that's, you know, the best park in Africa. I thought at that stage.
Yeah.
So I always had that idea, and I kept pushing, and I only got this job on I think the 4th time I applied for it. So it took a long time, and I had to just, you know, never lose faith that it will happen. So I think for the students out here, that's at the beginning of their careers, something doesn't work out, just keep trying.
Okay, thank you for that. Kirsten, we can take your question.
Hi, Corley. Thanks so much for your talk. That was really fascinating. I would like to ask whether you know, whether you have got a sense of the contrast between protected areas and what's going on outside of protected areas with human use and livestock, and what the effect on ecosystem function and structure would be.
So you know, it's interesting because I think bush encroachment, for instance, is still continuing outside, even though there's a lot of wood, you know, harvesting for wood. But I think that because a lot of the areas, especially if I talk now about the buffers of Kruger, there's very intense grazing, which weakens the grass layer, and then you still have bush encroachment happening, even though people are, you know, harvesting some of the wood. And you know, in that way, you do degrade the functionality of the system a bit. I don't know if that answers your question. Did you have a specific did you have a specific part of the ecosystem in mind, or just in general?
Yes, no, I think that's fine, Corley. I'm gonna think about it, but I think that you've answered it. Thank you.
Good.
We have a question from Tobile. She says, how can sodic sites be managed within a conservation area?
So, you know, unfortunately, because sodic sites are quite open and they're usually quite close to rivers, we in the old days used to make a lot of our roads on sodic sites, and then we realized that, you know, that just resulted in a lot of erosion because it has disturbed that topsoil layer. So I think for one, you know, one must be a little bit careful in how you manage it, so you don't make roads on sodic sites. But then animals just naturally like sodic sites. It's like very palatable areas. It's open also in terms of predators. You can imagine if you an impala and you need to sleep somewhere, you're going to prefer a sodic site because it's nice and open and you can see a lion coming from a mile away. But you can take the pressure off them a bit by, maybe burning patches away from the sodic site and creating those good grazing conditions. So there are ways of mitigating the impacts on sodic sites, but in a way, they are also designed to have high use by animals. So they might even look, we've had a site that actually looked completely ruined in terms of the state because it was completely grazed. It looked like there was not a blade of grass. And we fenced it, and within one season, just after some good rain, the grass was up to, like a meter tall. So I think they're just very productive systems. They look like they are overgrazed, but they actually, they're still fine. They're still very productive.
Okay, thank you. I know we have the students for an hour and we have 7 minutes left. So I'd like to close the Q&A and ask Tobile to unmute herself and we hear from her.
I also saw there was a question in the chat if we have time.
Oh, from Asima, yes.
Yeah.
Would you prefer the savanna to be bushy as there are some animals who ambush the prey?
I think the best savanna is a savanna where you have all different types. So you have areas that's very open, you have areas that's quite close in terms of trees, and then you have these areas that's in between. So we have animals that prefer to be open. We have animals that prefer to eat grass, so they want to have good grass. There's animals that like to hide their babies in tall grass, so we want to accommodate them. And then we have black rhinos and elephants that prefer to eat trees. So I think like a savanna where you have a lot of heterogeneity and a lot of variability is probably going to give you the best in terms of diversity of animals.
Okay, thank you. Tobile?
Hi, Dr. Kali. Thank you so much for today. Let me just tell
Hi
you.
there.
Yes, thank you so much for today. We appreciate you and your time. Hi, I think I've seen you before though, but yeah, thank you.
Probably.
Yes, you've covered quite a lot of what we've covered in class, and I appreciate that. It was 100% relevant. And I saw a soil profile that is dark already within your slide. And I wanted to know, how do I get one dark in the Kruger Park? Because I want to collect some soil samples for our lab, actually.
Anyone is welcome to do research in the Kruger National Park. We have an online application process. So if you just Google project registration, scientific services, then you will get that site, and you can register and put your project there. It's going to ask you some questions. What's the background? What do you intend to do? And we don't charge researchers, so we don't charge a permit fee. So we try and make it easy for people to come, and we have subsidized research accommodation in our research camp. So I think it's quite easy compared to, I think East Africa's got many more hurdles in the way of doing research. And then if it's a master's, PhD and up, then there's a bit of a process where we register the project. But if you are an undergrad student, I think you can just fill that in, and then it goes to our little meeting where we discuss it. But most of the time we'll just let the students come and do their little project. So And if you email me, I can also give you our science liaison person, Samantha Mabuza's email address.
Thank you. Just because this is specifically for the lab, it's for the students, because what we do, we have to test for texture when we classify the soil into different soil forms. So all those processes, we want to do them in the lab, not going to the field, because we only have one field excursion, which is in Ermelo, like this coming September every year. But then the practice before then is very important, because even in the third year, when they are doing their management plan outside in the field, they have to do this process alone. So having enough time to test that, it's very important for the students. So what I was saying, that if I'm not collecting for a master's or a PhD, but
Okay,
only
so we also
have it in the lab.
We also have learning programs. So I think like if you email Samantha and just explain what you want to do, then that can be definitely arranged.
Okay. Thank you. Thank you so much. And thank you for the lovely talk and your time in putting it together. We appreciate it.
You're very welcome.
Thank
And
you.
ladies and gentlemen, it's 2 minutes before 1 o'clock, and to echo Tobile's words, this was a great, great conversation. Thank you, Dr. Coley, for sharing your expertise with us. And for the students, I think more than just learning about soil, it was a reminder on resilience and passion. And so I hope everybody enjoys the rest of the day, and see you again next week.